In this next lesson, we're going to look at conditional probability. We're going to start by looking at the complement of the probability of A. If something has a probability, let's say that the probability of A is 1/3, then the complement of the probability of A would be 2/3. That is to say, if you take the probability of A and add it to its complement of A, let me put the bar over the complement, you should get a probability of 100%, or 1. And when we talk about the complement, that's the probability of not A. That is to say, if we have a die and the event A means that we are going to roll the die once and get a 2. Well, the probability of A here is that if we roll the die once and get a 2, that will happen. Well, there's one side of the die with a 2, and the total number of sides on the die is 6, with only one side having a 2 on it. So the probability of rolling a 2, where A is the event rolling a 2, the probability of A is 1/6. The probability of the complement of A is the same as the probability of not rolling a 2. Well, there are 6 sides in total, that's our sample size, but our event size is 5. We could roll a 1, a 3, a 4, a 5, or a 6. So there are 5 possible sides that do not have 2's on them. So the probability of the complement of A is 5/6. So in this case, if you take the probability of A and you add it to the probability of the complement of A, you end up with 6/6, which is 1, and 1 is equal to 100%. And looking a little further is that the probability of the complement of A is equal to 1 minus the probability of A. Or rather, we could say that the probability of A is equal to 1 minus the complement, the probability of the complement of A. In this next slide, we're going to take a look at the fact that the probability of A is equal to 1 minus the complement of the probability of A. So we're going to take a look at the following probability. Find the probability of having at least one boy among 3, and this should say births. Let me fix this. Among 3 births. So there are going to be 3 births, and each birth has a probability of having a boy or a girl. So the probability of having a boy is 1/2. And the probability of having a girl is also 1/2. And of course, the sum is 100% that you'll have either a boy or a girl. If we want to know the probability among 3 births of having at least one boy, in 3 births, well, if you think about that, the probability of having at least one boy in 3 births is equal to 1 minus the probability of the complement of having at least one boy in 3 births. So let me grab this. I'm going to take this and I'm going to copy that and resize it. I'm going to make it small. Let me copy that and paste it, and I'm going to resize it because it's rather large and move it over here. Okay, let's put it here. Okay, so the probability of at least one boy in 3 births is equal to 1 minus the complement of the probability of at least one boy in 3 births. Let me grab this. This is getting a little bit messy. I'm trying to clean this up here. Let me clean this up. Okay, and let me get rid of this. So I rewrote this so that it's a little bit easier to read. Okay, so here we have, here's our statement, our mathematical statement. I'm going to move this up. Okay, so the probability of at least one boy in 3 births is equal to 1 minus the complement of the probability of at least one boy in 3 births. Well, this becomes 1 minus the probability of the complement, which means not having at least one boy in 3 births, would be to have 3 girls. Would be have a girl, and then a girl, and then another girl. So in 3 births, you'll have a girl 3 times, which means no boys. So the probability of the complement of at least one boy would be no boys, all girls. And what is that? That would be 1 minus, and here we use our multiplication rule. Well, the probability of having the first girl is 1/2, and this is actually, we'll write it out as probability. The probability of having a girl and then a girl and then a girl is the probability of having a girl times the probability of having a girl again times the probability of having a girl a 3rd time. And that is the probability of the complement of at least one boy, which is the probability of all girls. So that becomes 1 minus the probability of having a girl is 1/2, and again of having another girl is also 1/2, and then again the probability of having a girl is 1/2. Here's our multiplication rule. These are independent events, so each one is multiplied by the one before. And this becomes 1 minus 1 over 2 times 2 is 4 times 2 is 8. And 1 minus 1/8 is 7/8. So the probability of having at least one boy is 7 divided by 8. And so let me put that into the calculator. And 7 divided by 8 is 0.875. Moving our decimal point over twice, that gives us 87.5% probability of having at least one boy among 3 births. So this is a way of using your complement of a probability to find the probability. Now moving on further, there are times in conditional probability notation we want to know the probability of B given that A has already occurred. Now, let me explain this. Let's imagine that A means, the event A means that we have selected a male. So we have this set of people, males and female, soccer and lacrosse players. So A means we select a male. And B means we have selected, we've selected a lacrosse player. So we want to know what is the probability that we select a lacrosse player given that we have already selected a male. Well, if we've already selected a male, we've now reduced our sample size to include only males. And if you add the number of soccer males to the number of lacrosse males, we have 5 plus 2 is 7. So here we want to have the probability that we would select a lacrosse player from our 7 males. So that's going to be our event size over our sample size. When we do probability, it's our event size over our sample size. And because we know that A has already occurred, that we've already selected a male, our sample size is reduced to 7, and the probability that we would select a lacrosse player from these 7, well, there are 2 lacrosse players, so there are 2 possible ways we could select a lacrosse player, which means the probability of selecting a lacrosse player, given that we've already selected a male from our set of male and female soccer and lacrosse players, is 2 over 7. And if you put 2 divided by 7 into your calculator, you will get 0.2857. Okay, we want 3 significant digits. 2, 8, 5. Those are our 3 significant digits. So I would say this is approximately equal to 0.28, and the 5 is rounded up to a 6 because the 7 is 5 or greater, and this is equal to 28.6% probability that we will select a soccer player, given that we have already selected a male from our set of male and female soccer players. So this concludes our lesson on conditional probability.